Welcome to Physics World Online College, where the knowledge of physics is explained in simplest terms for you to understand and be able to do very well in your exams. In our class for today, meant for SS1 ST1 students, we shall consider the topic speed as a follow-up on the last two topics, distance and displacement. So for our class of today, we will discuss the meaning of speed and other variants of speed, such as average or mean speed, uniform or constant speed, instantaneous or variable or non-uniform speed. Please remember to share this class video with your friends in other social media sites so that they will be aware of what is happening in this channel. Let's continue. We say that speed is defined as the time rate of change of distance or the rate of change of distance with time. Speed is a scalar quantity. What does that mean? That speed has only magnitude but no direction. Speed has its SI unit as meter per second. But there are other units of speed such as kilometer per hour or centimeter per second. However, the SI unit of speed is meter per second. Let's put those information down. Speed is defined as the time rate of change of distance or the rate of change of distance with time. And I said it is a scalar quantity, meaning it has only numeric value but no direction. By formula, that is mathematically, speed is distance divided by time. Speed equals distance divided by time. So if you are asked what is the formula for speed, simply say speed equals distance over time. Now, the unit of distance is meter. And when I say unit, I'm referring to SI unit. So the SI unit of distance is meter, while the SI unit of time is second. Now, if you divide meter by second, you will get meter per second, written this way, meter. That divide becomes slash, forward slash, then second. So we call it meter per second. Or you can write it this way, meter second. That per becomes minus 1. So we call it meter per second. So you can express it this way or this way. Take note of that. So I said the SI unit of speed is meter per second. Now, let's take the other variant of speed. Let's call that number 2. Let this be number 1. average or mean speed. This is defined as the total distance traveled divided by, or you say over, the total time taken. We can put that also in formula as, that is, or we say mathematically, average or mean speed. Average speed equals total distance traveled over total time taken. Over total time taken. Now, let's take a little illustration for this average or mean speed. If we have a body that moves from a point A to a point B and the distance is 6 meters, taking a time of 2 seconds. 2 seconds. Then it moves from point B to point C, a distance of 7 meters, taking a time of 3 seconds. And then from point C to point D, a distance of 10 meters, using a time interval of let's say 5 seconds. Now, let me change this time to 1 second, and let me change this time to 6 seconds. Okay. Now, to get the average speed of this body, we will have to add all the distances and divide it by, after adding all the time. So we will have 6 plus 7 plus 10 divided by 1 plus 3 plus what? 6. If we add together, 6 plus 7 is 13, plus 10 is 23, divided by 1 plus 3 is 4, plus 6 is 10. So 23 divided by 10 will give us 2.3 meters per second. You see that the unit of average speed is also meter per second. All the speeds have the same unit, which is meter per second. That is SI unit, of course. Now, we take the next one, which is uniform, number 3. Uniform or constant speed. A body is said to be in uniform speed, when it covers equal distance in equal time, no matter how small the time interval may be. No matter how small the time interval may be. Now, the key point to take note of here is equal. Now, whenever a body moves with uniform or constant speed, it means you have equal distance in equal time. In fact, going forward, know that anytime you hear uniform or constant and then a quantity, then you have to be talking about equal of the numerator, the quantity in the numerator, divided by equal of the quantity in the denominator. What am I saying? Uniform or constant speed. Speed is a quantity, and I've said speed is distance over time. Now, once I'm saying uniform speed, I will say equal distance over equal time. In the next class, we will talk about velocity. When I'm not talking about uniform or constant velocity, velocity is displacement over time. I will then say equal displacement in equal time. So take note of that. Then, I can also define uniform or constant speed as saying a body has a constant or uniform speed when the time rate of change of distance is constant. What does that mean? If I borrow this illustration here, this previous one, it means that the body moves from point A to point B, then the distance, the first distance 6 meters, and the time 1 second will remain so. As it moves from point B to point C, it will cover same distance 6 meters using the same time 1 second. As it moves from point C to D, it will cover the same distance 6 meters using the same time 1 second. So you see that the distance covered is equal. Then the time taken is also what? Equal. So once the distance is equal and the time is equal, what you will have is what? Uniform or constant speed. Now, we can obtain uniform or constant speed from a graph of distance against time. So we say if we have a distance time graph and we take the slope or gradient of that distance time graph, we will get uniform or constant speed. What am I saying? Let's take the graph. This is a graph. Distance in the vertical axis. The unit of distance is meter against time in the horizontal or vertical x-axis. The unit of time is second. So this is distance time graph. The origin is 0, 0. So if the body moves with equal distance in equal time, the graph will be a straight line graph passing through the what? Origin. So if you get the slope or gradient of this graph, this distance time graph, the slope or gradient will represent the uniform or constant speed. So we say slope here is equals to the change in the distance over the change in the time. So change in distance over change in time. Here this slope represent the what? Uniform or constant speed. So what point am I establishing here is that the slope or gradient of a straight line distance time graph represent the uniform or constant speed. That's the point I'm making. Let me put it down. Note that the slope or gradient of a straight line distance time graph represents the uniform or constant speed. The uniform or constant speed. That is the point. It's a popular question they normally ask in exams. So you should take note of that. Let's move and talk about the next quantity, number 4, that is variable speed or non-uniform speed or instantaneous speed. Now, variable speed or non-uniform speed now, when the body covers a distance over a period of time and it is not equal, it is not equal distance in equal time, then what the body have is what we call variable speed. That is, the rate of change of distance with time is not uniform. We call it variable speed or non-uniform speed. A body is said to have non-uniform speed when the time rate of change of distance is not constant. It's not constant, or you say is non-uniform. Now, for such body, you can only determine the speed at a particular instant in time. And when we determine the speed at a particular time, we call it instantaneous speed. The speed of such body can only be determined at a particular instant in time. Hence, it is also called instantaneous speed. Instantaneous speed. So, what am I saying? That instantaneous speed is the speed of a body at a particular instant in time. Now, if we have a graph if we have a graph, distance time graph, illustrating variable speed or non-uniform speed or instantaneous speed, that graph will not be a straight line, rather it will be a what? A curve. So the distance time graph for variable speed, if you are asked to draw the distance time graph for variable speed, this is what you will draw. You will draw a curve. Look at it, showing that the distance is changing with time. So you have a curve and not a straight line. So for this body, you can only determine the speed at a particular point. Let's say the speed at point A, or the speed at point B, or the speed at point C, or the speed at point D. Now, how will you determine the speed at a particular point? That is the instantaneous speed. You will have to find the gradient at that point. So the instantaneous speed is the instantaneous speed at point A is the speed at point A. What I will do, I will take a tangent at A and find the change in distance over the change in time. So the gradient at point A give me the instantaneous speed at point A. I hope you get what I'm saying. So the gradient at point B, if I take gradient at point B, I will take a tangent at that B, form a triangle, take the change in the distance over the change in time at that point B, gives me the what? Instantaneous speed at point B. Now, having gone through each of these terms, we can solve a particular example as we have here. So let me take this point now before I solve the example. I said the gradient also means slope. So the gradient or slope at point B is the instantaneous speed at point B. And if I want to obtain it, I said I can call it VB is equals to the change of the distance at that point B over the change in time at that point B. So this gives me the what? Instantaneous speed at B. I can also obtain this instantaneous speed at A, at C, at D using similar what? Formula. Now let's take solution to example that we have. Now I want to sum these points that you need to know. Whether the question is saying speed or average speed, as you have in this assignment here, they all refer to what? Speed. And I told you they have similar formula and similar what? SI unit. I hope you get that point. So here we are told that a bus traveled 225 kilometers in 5 hours. For us to find the speed, the question could have been to find the average speed like you have here. Is the same thing you were saying. Now we will find the speed in kilometer per hour, and then we will also find the speed in meter per second. Let's obtain that. So we say given. We are given from the question They gave us the distance. The distance D is given as 225 kilometers, and we are given the time T as 5 hours. Now, the first part say we should find the speed in kilometer per hour. To find the speed in kilometer per hour means the distance will be in kilometer and the time will be in hours. I don't need to convert in that case. So I will take 225 divided by 5. 225 divided by 5 give me what? 45. Here, the unit will be what? Kilometer per hour. So I use the distance in kilometer and the time in hour. So the speed will be in what? Kilometer per hour. Kilometer per hour is a unit of speed, but it is not the SI unit. Hence, we are asked to find the speed in meter per second. That one is the SI unit. So what you are going to get here is to learn how you can convert kilometer per hour to what? Meter per second. In fact, let me take it as a mini sub-heading here. Conversion from kilometer per hour to meter per second. That's what we want to achieve here. So what are we going to do anytime you have to convert from kilometer per hour to meter per second? So you take the speed 45 kilometer per hour. Now I will represent this 45 as 45 times 1 kilometer divided by 1 hour. Remember, I told you this per means divide. So that kilometer per hour means 1 kilometer divided by 1 hour. Now, I will now convert that 1 kilometer to meter. 1 kilometer is 1,000 meter. So I replace that 1 kilometer with 1,000 meter. And then 1 hour in second is 60 times 60 in second. This first 60 convert the hours to minutes, while the second 60 convert the minute to what? Second. So what am I saying? If you are given any value going forward, speed, and it's in kilometer per hour, but you are required to convert it to meter per second, which is the SI unit of speed, then simply multiply the value by 1,000 and divide it by what? 60 times 60. If you do that, you will simply arrive at, here I have 12.5 meter per second. You press your calculator, you have access to calculator. You have 12.5 meter per second. So I have converted the speed from kilometer per hour to meter per second by simply multiplying the value by 1,000 and dividing it by what? 60 times 60. I believe that point is noted. Now, once you are given a formula, you can be asked to find anything, any of the quantity in that formula. All you have to do is to make it the subject of the equation. What am I saying? We say that speed is distance over time. Now, if you are given the speed and you are given the time, as we have in this assignment number 2, then if you cross multiply, it means that distance is equal to what? Speed times time. To find the distance, multiply the speed by the time. That's 1. 2, you see that the speed here is given in kilometer per hour, whereas the time is given in minutes. You cannot use kilometer per hour together with minutes. No, it means you have to convert this kilometer per hour to meter per second using this method I've said. Then this time that is in minutes, you will have to convert it also to what? To second. How do you convert from minute to second? Multiply by 60. So before you can now determine the what? Distance. Using the formula, distance is equals to speed times time. Because I have said if you make distance the subject of formula here, you will get speed times time. Good and fine. The question also can also be, you are given the speed, you are given the distance, they say find the time. What you do, you make the time the subject of formula. And if you make time the subject of formula here, you will have distance divided by speed. So that is something you need to learn as you continue in this study of physics. So I've told you here that they say find the average speed is the same thing as find the speed. Just do distance over time. But where necessary, you have to convert. Now, there's one more point I should make. Now, this speed that I obtained by finding the speed first in kilometer per hour and then converting it to what? Meter per second. Assuming I was not told to find the speed first in kilometer per hour, they just wanted me to find it in meter per second directly. Then another method I would have used here in this option B is I will have to first convert this distance to meter separately by multiplying by 1000 and then converting this time 5 hours to second by multiplying it by 60 times 60 before I will now apply that new converted value into the formula distance over time. By the time I do that, I will now have the speed directly in what? Meter per second. Please do this assignment and submit your answer to me. I will attend to it appropriately. Thanks for your time. Bye bye.